Hi, I'm Kevin, and this is Iteration Station. Welcome back. Today we're going to do our first iteration of creating a switch for a water heater using our Jupiter I board that's wireless. It'll be using an RF signal. And the water heater that we have in this RV is an old aftermarket edition that the plug-in is in a receptacle in my closet, which isn't very convenient, as you can imagine. So what we want to do is have it to where I can control it from my GUI on my touchscreen. And also I'm going to put do a little wiring, and then we're going to add a switch and a light so I can manually turn it on and off if I want to go outside of what I've programmed into the computer. So follow me back here and I'll show you the GUI real quick. We won't spend a lot of time on this. This GUI is a lab GUI, and I'll go over that later. If you follow all the way to the end of the video, you'll actually see this GUI actuate the switch. And then what we're going to do now is we're going to go ahead and show you how I assemble the panel that's back in this hole that has all the components on it: the Jupiter I/O board, the computer, LAN network, the RF signal generator, and some different components that are on there. We'll go over that in detail if you follow along. And also, as you follow along, there'll be tips and tricks of things I do to manufacture this kind of stuff. So I hope you join us and follow us all the way to the end and see this thing actually work. If you use a gun tap, you can, they're called spiral taps or gun taps. You can use a power drill, even on metal, and drill and tap holes without having to back up and do it by hand. It saves a ton of time. And the reason you don't have to break the chip on these is if you look at the tip here, it's got a bevel there, a relief there. And what that does is, as it's cutting the threads, first of all, it cuts the threads a little bit at a time at the first two, they're tapered. And then by the time it gets to full thread depth, the chip that comes out of it gets shoved down. So the chip goes down where a normal hand tap, the chips stay up in this area and they bind up and you have to keep backing it off. But the one thing you have to watch when you use this type tap is if you have a bottoming hole, those chips are going to go in and fill up the bottom. And if you power tap into a bottoming hole that doesn't have enough chip clearance, then it'll bind the tap up and can break the tap. We're going to go ahead and peel the protective coating off this on one side here and start mounting a few things. This is the strap I made. I'll show you how I drew it in 3D CAD, what program I used, and 3D printed it. It took me about, I don't know, 10-12 minutes to print it and probably 10 minutes to design it. So that'll fit right over here, and I'll strap that down. Okay, now the panel you just watched me assemble is now in the RV. You can see it's all completely assembled. Once again, this is the RF signal generator. This is the Jupiter I/O board from Lightwave Precision. This is the computer, power source, Wi-Fi, and this is a TPMS that was already there. I just worked around that. That's a range extender for that. Now, what's going to happen is we're going to put a switch in the bathroom, and I'll show you how we're going to do that, and also the box that's going to trigger the power to the actual heater. Okay, we're going to go ahead and get the switch mounted on the wall, the manual switch with the light. So I'll flip the camera around and I'll show you what we're doing here. We've got holes drilled already for the mounting. I'm going to go ahead and drill a hole in the center to give the clearance for the switch. Go into the wall. Making sure that I don't take out my holes for mounting it. Let's see, that looks pretty good. Now, as you can see, we've got our control panel, our control box. It's taking the signal from the Jupiter I/O board and feeding it into the plug-in. But the box up there then will turn the switch on and off. And this wiring is temporary, just for temporary purposes. I'll try to get you an image of it later in the video with it cleaned up and the wiring done directly to the plug. Here's a quick tip for you guys this morning. If you're cutting a thin piece of material, say brass or sheet metal, and you want to have it cut pretty burn free, whether you're using a CNC like I am, even a saw or a drill, anytime you try to drill something thin, you're going to get big burrs. Then you have to try to clean them off, and normally you'll end up scratching your surface. So what you can do is you can take a piece of material like I've got this piece of leftover Lexan here. It's thin. You sandwich your brass piece in between the two pieces of plastic. Then when you cut, whether you're cutting by hand or cutting with a CNC, it'll leave a burr-free finish because it's trapped between two pieces of material. Or normally when you cut through it, we push a burr out the back side because the drill bit has a point on it, or the cutter has a way to make a burr on it. So I'll go ahead and cut this out and show you the end result. There you go. Now when I clean this up, it should be fairly burr free. Got a little debris on it. With a drill bit, you'd have big burrs on the back side. I did touch it with sandpaper just slightly, just to give it a nice finish after I cut it. There was a little debris on it. But I mean, I had nothing really to speak of to take off, where if you tried to drill this and cut this in a saw. But if you another thing you can do is if you get some clear double stick tape and put it between your sandwich stuff, that helps. So I wouldn't have to clean it up at all if I'd done that. I didn't have any today. But if you stick that and sandwich it together, you can put that in a bandsaw or a drill press or whatever and drill it, and it'll come out burr free like this. And this is the switch and switch plate bracket that we made and the light. And as you can see, it's on. If I want to turn the switch on and off manually, we wouldn't have had to have this switch, but I kind of wanted to be able to turn it off manually if I wanted to. So, you know, just typical switch. If you want the heater on, heater off type thing. But also it can be automated through the Jupiter I board where you don't have to do the switch at all. As I showed you before, we've got our touchscreen here, and the touchscreen has our lab GUI on it. This will not be the RV GUI that we'll create for people. We created this, but it's mainly for lab work. But it will work for the purposes of showing this demonstration. It's pretty nice, but it's got lots of buttons and numbers in here and stuff, but we're only going to be using this top button today. The very top button is what we're going to use to actuate our switch. Now what this does is the computer is going to, when I actuate the switch, it will tell the switch to operate with an RF signal. When the RF signal hits that switch, it's going to turn the box on to create power. And then when I hit it again, I can turn it off. And if you swing around there, I can show you how it's working. I'm hitting the switch, turn it on and off. If you come back here, you can see that the switch on the board also lights up. Every time I hit the switch, it lights up and turns off. So you can monitor it at both places. Now the beauty of the Jupiter I/O board and the computer together is that the Jupiter I/O board's given us the signals to make this thing actually operate. But what happens is I've got computer control like a home automation then at that point with the data acquisition. So I can tell it I want to have it turn on for 15 minutes or 5 minutes or 2 hours. So I can actually have it pre-programmed just like you do your phone or whatever, where if I'm camping and I want to get up at 6, I have it turn on at 5:30. The water's warm when I get up. I give myself some time to get a shower and get my breakfast made, and then it turns off. So we're not using any extra energy. The whole point of what we're doing here is we're going to try to make this a boondock type machine where I can go out in the middle of nowhere, have no power, and use my power the very most efficient way possible. We need to save every watt we can, and something like a water heater is using somewhere between 500 and 1,000 watts. I can also automate a coffee pot. Basically we can automate anything. My point is, with this Jupiter I/O board, anything you can dream up, it's open source. You can write your own code and do anything you want to do, or we can write a code for you to make sure that it'll do any operation you want to do. Just dream something up and we'll make it happen.